here. Okay, so when you look at the information, again, as you set it up, you identify the pattern that's provided. You have two sides in the non-included angle. SSA. SSA tells you you're using law of sines. Okay, so now determine, are there one solution or two solutions? So when you look at this, the longest side is opposite the given angle, so can we hinge this and create another triangle inside here? No. So there's just going to be one solution. And so now you can begin, and we begin by using the law of sines. So we have our set ratio right here, okay? And so let's call this triangle ABC with side B. So what we want to do is we want to find angle B, angle C, and side B. Okay, so which of these pieces can we find first? Good. So here's our set ratio. The other piece that we have is 10, so we have to find the angle opposite it first. So those are the pieces that we solve for. So we're going to set up a law of sines. So our unknown is an angle, so I'm going to start with that, put it in the numerator. Sine of C over the side opposite at 10 is equal to the known ratio. Since I started with angles on top, I'm going to use the sine of 21 on top over the side opposite at 15. And so here's my calculation. So I'm just going to use the solve feature in my calculator. And remember, I talked about this already. Your calculators can't use the solve feature to solve for an inverse trig ratio. So you have to do one of two things. You either have to calculate by hand, bless you, bless you. Okay, or what you can do, and what I'll do on all my examples, is just substitute in a value of x for that trig ratio. So I'm going to let x be sine of C, and then I'm going to just solve for x here. Okay. All right, so what I'm going to do is I'm going to discontinue the projection out to your screens. I'm only going to project up on the wall here as I finish this because I need to use or open the calculator for this. Okay. It's all based on whether when you're looking at this SSA pattern, if the shorter of the two sides is opposite the given angle, you have two solutions. If the longer of the two sides is opposite, you have one. So if I go through and I calculate, I use the algebra, the F2 algebra tab, choose solve, type my equation, x divided by 10 is equal to sine of 21. I'm going to put a decimal point in this so that I get my answer in decimal form. I could have also used the green diamond button. But that over 15, comma x tells the calculator what I want to solve for. All right, so I'll be talking about making predictions for values anytime you're using your calculator. And I think I mentioned it before, but the sine and cosine ratios for any angles always have to fall between -1 and +1. Okay, so when you're looking to solve for x here, which is a sine ratio, it has to fall, but it has to be some decimal value between -1 and +1. So when I hit enter here, I confirm that point 2389, it fits that condition. Okay, so if I substitute that directly in for x here, I get 0.2389 is equal to my sine of C. Therefore, to solve for C, I'm going to take the inverse sine of that ratio. Okay, so if I use my calculator, the inverse sine is green diamond y. And then I'm going to go highlight this measure. Now, I have to make a choice here. Do I want to leave x equals in the calculation? Eventually, you're going to have to delete it anyway. So what you'll see me, I'll always just delete the x equals from here. So I'm going to delete that to get my new answer because I'm going to have to use this again in my calculation. Okay, so I get my angle measure to be about 13.8. Or I'm sorry, the angle C is 13.8. Right. So the next thing I need to do is find angle B. How can I do that?
You can add the 13.8 to 21.
Perfect.
And then 180 minus that number.
All right. So if we use the triangle sum condition, we know that the sum of all those angles has to be 180. So if we remove 21 from that and we remove 13.8, but again, use the exact value. So highlight it in your calculator and pull down the exact value for that and hit enter. You get 145.2. So this angle is now solved. And so we have one final calculation. That final calculation is to find the length of B. And you can find the length of B by setting up and solving another law of sines. Right? You have an unknown sine over the sine of the angle opposite it. So even though I'm writing 145.2, when I calculate it, I'm going to use the exact number. And set that equal to our known ratio. The given ratio is sine of 21 over 15. But since my side is being used on top, in this new ratio, I'm going to put 15 on top, sine of 21 in the denominator. And once again, I'm just going to solve for my unknown. Okay, so here I use the F2 algebra tab, type in my equation. I'm going to type in an x instead of the b, just to make it easier. The sine of 145. So again, I'm just going to highlight my exact answer, pull that down, set it equal to 15 divided by sine of 21. I already have a decimal here, so I don't need to put any more decimals or use the green diamond. It's already going to give me my solution in decimal form. Tell the calculator what I want it to solve for. So I want it to solve for x. Now, before I hit enter here, again, I'm going to make a prediction. Okay. When you look at this triangle, is B going to be the shortest side, middle side, or longest side? It has to be the longest side, right? Because it's opposite the greatest angle. So in looking at that, we know it has to be greater than 15, right? But what's the upper limit? What's the ceiling of what it can be? Again, when you use triangle, the triangle inequality, you know that it has to be smaller than 25. So we know it's going to be somewhere greater than 15 but smaller than 25. Does everybody see how I got those? And the usefulness of making that prediction is it gives you just a little more confidence that you have the right answer. Now, 145 is quite a bit away from 21 or 13.8, so we're probably going to be closer to 25 than we are to 15, right? So that's my prediction going in. It's going to be some value less than 25, but probably close to it. So when I hit enter, I get 23.9. Does that fit what I was predicting? Yeah, if it's consistent, it at least gives you some sense that you are correct or at least consistent with what you were expecting. Okay. So this is SSA using law of sines to find a triangle with one solution.